Arduino IDE software, the Arduino open source development environment. Coming from the acronym, Integrated Development Environment. Do you know all its functions? How to download and install it on our computer. How to find and use the examples. How to set your editing preferences. How to change the font size. How to change the scale of the program editing interface. How to change the interface theme. How to change the language of the graphical interface. How to activate AutoComplete. How to comment on a code selection, and how to uncomment. How to compile and upload a program to the Arduino board. What options do you have to use an external programmer? How to compile hexadecimal files, to use them in Proteus or any other simulation software. How to install and include a library in our code. How to configure and use the serial monitor. And the serial plotter. Where and how to install resources to be able to program boards from manufacturers other than Arduino, such as the ESP32, or the ESP8266. Where to find documentation on Arduino programming. Where to check and update the Arduino IDE, without losing anything that has been developed up to that point. All this and more, in this video where we will learn about all the functions that the Arduino IDE development environment has available. To install it, we go to the browser of our choice, and type the official Arduino website, arduino.cc. On the Arduino website, we enter the Software tab. And here we can see access to a recent Arduino tool, which allows you to edit and manage code online, or in the cloud. Below in the Download section, we will find up to the date of recording this video, the latest available version of the Arduino IDE, version 2.3.2. And on the right side we find the download options, for Windows 10 operating systems onwards, for Linux systems, and for Mac systems. In my case I will choose the executable installation package for Windows 10. It will take us to a new window, where we can choose if we want to contribute money to the continuous development of Arduino, since it is an open source system and many people constantly improve and update it, or choose the option to only download if we are not going to make no contribution. In the next window, we can put our email in case we allow weekly updates about Arduino to reach our email. In this case, I will select the box accepting the terms and conditions, and click on Download Only. It will start the process of downloading the installation file. And once the download is complete, in the upper right, we click on the executable file, and in a few seconds the installation wizard will start. We accept the license agreement. Then I will select that only I will use this program on this machine, and I click Next. Then it shows us the path of the destination folder where the Arduino files will be installed. I will leave it as it is, and I click on Install. It will start the installation process. And once it's finished, I click Finish. When the installation is complete, we can see the Arduino IDE program icon on the desktop. We open the program. In the graphical interface of the program, we can see a top horizontal bar with 5 tabs. The File tab. The Editing tab. The Sketch or Program tab. The Tools tab. And the Help tab. We find a lower horizontal bar, in which we can see the Verify button. The Upload button. The Debug button. The selection list of the target board. This will be the board to which the code that we create will be loaded, since we can have more than one board connected to the multiple USB ports available on the computer. At the far right of this bar, we have the serial plotter tool, and the serial monitor tool, of which we will see how they work later. At the far left of the interface, we see a vertical bar with 5 icons, and in which we can see the sketchbook icon, where we will find the codes that we make locally, that is, on our computer, and the codes that we make in the cloud, that is, in the Cloud Editor, or Arduino Cloud Editor. We have the Board Manager icon, where we find characterization packages for different development boards. This means that we can install different boards, additional to those that are predetermined when installing the Arduino software. We will see how to use this Board Manager later. We have the Library Manager icon, in which we find multiple libraries developed by Arduino, or developed by third parties that meet the minimum Arduino requirements to appear listed here, and that help us work more comfortably in programming our codes for Arduino. We will see later how to install a library from this manager. We find the Debug icon, which allows us to debug the program that we are going to execute on the development board, and which here informs us that this function is not available for the Arduino Uno board, which is the one we have selected in this moment. We find a search icon, where we can search for words or expressions within the code editor. And at the end of the vertical bar we find an icon to access the Arduino code editor in the cloud. And of course, we find in this interface the local code editor tab, where we will edit or develop the code or program that we will upload to the development board of our interest, in this case an Arduino-compatible Uno board, which we have connected to our computer via a USB cable. In the File tab we find the New Sketch option. If we select it, a new window will open, and if we select it again, a new window will open, and thus we can open as many objects or windows as codes we need to create, taking into account that the development board will be able to execute only one of these codes at a time. Then we find the New Sketch in the Cloud option. In case we want to integrate our codes in the cloud with our local Arduino editor on our PC, this option will remain disabled until the Arduino cloud is entered. We find the Open option, which will allow us to open sketches or programs that we have previously saved on the computer. We find the Open Recent option, where we will find a list of up to the last 10 most recent programs that we have created. In the Sketchbook tab, we will find a list with all the codes that we have previously created in this editor. Then we find the Examples option, one of the most important in this development environment. Since it includes a list of basic examples applicable to almost all types of development boards, and that serve as a starting point to know how to make a program to execute a specific task in Arduino. And we find for the moment a list of examples for the Arduino Uno board, since it is the development board that I have selected at the moment. We are going to enter the basic option, and we open the blink example, which is a basic example to blink the LED built into the Arduino Uno board. After the Examples tab, we find the Close tab, to close the software. We find the Save option, to store the program on our computer. The Save As option, which we will use to save this example, with our own name, I will call it Test Blink. Once saved, the name indicated will appear in the upper left. Continuing on the File tab, we find a very important option called Preferences. In it we find the Settings tab, and where we find the location where the sketches or programs that we create will be saved, which is usually found in the path, My Documents, Arduino. With this box we determine whether or not all files in the specified folder are shown. We find the size for the font, or the editor's font size. We can increase it, and click on OK, for which we will have a larger font. It only affects the size of the font. And we can decrease it, and click on OK, for which we will have a smaller font. We have the option of the interface scale, which, if we increase its scale, and click on OK, we can see a larger interface, not only the letters, but also the icons or buttons that make it up. And if we decrease the scale, and click on OK, we will see a smaller visual interface. In the Theme option, we find a selection list, where we have the Clear option, which is the one seen on the screen. We have the Dark option, which is shown on the screen. We have the Clear option with high contrast. And we have the Dark option with high contrast. Personally, I like to work with a light option without contrast. In the Language option, you can select the language of your preference. The visual interface options of the Arduino environment will be illustrated in the language you select. Then we find an option with two checkboxes, in which you can select whether detailed information is shown in the system output during the compilation of the program, or if it is shown during the upload of the program, or both. We will see later that refers to system output. We find an option with a selection list, to determine if warnings are shown in the system output when compiling or verifying the program. I will leave it selected to none, so that it only shows me when there are errors, not warnings. Then we find a box where we select whether or not we want the Auto Suggestions function. If we activate the box, and click on OK. While we write our code in the editor, recommended options will appear trying to auto-complete our writing more quickly. And finally in the References, we find an icon for the Resource Manager or URLs for additional boards. If we click on the icon, a text box will be displayed, where we can place the web addresses or URLs, from where we want to extract the characterizing resources for additional development boards, which are not predetermined in the Arduino development environment initially. That's right friends, With this Arduino environment, we can also program development boards from other manufacturers other than Arduino, such as the ESP8266 boards, or the ESP32 from Expressive, the STM32 boards from STM Electronics, or the Tiny Boards Digistump, among many others. We will see later how this URL Resource Manager is used to install additional boards. Continuing the File tab, we have the Advanced option, where we find a Keyboard Shortcuts option. If we open it, a new tab is displayed where we can see all the functions of the key combinations that allow us to write code more quickly without having to use the mouse, only with the keyboard. We also find an option to show or not the code stored in the Arduino Cloud Editor, only in case we are logged in and integrated into it from our local computer. And finishing the File options, there is the Exit tab to close the entire Arduino development environment. In the Editing tab we find the general options of any word processor such as Word or others. The Undo option. Redo. Cut. Copy. Copy formatted for Arduino Forum. Paste. Select all. The Go to Line option. Since the code editor is numbered, we can type a specific line number, which will position the editor highlighter on the specified line. The Comment/Uncomment option is very important, because it allows us to select a text in the editor, and comment on it with a single click, saving time in code development testing. Likewise, and with the same click, we can uncomment it. We have the option to increase indentation, to separate the beginning of the selected lines of code by a space. And with the decrease indentation option, to close this initial space of the line of code. With the increase font size option, we can increase the font size of the editor, applicable to the font inside the editor. And we can reduce the font size with the opposite option. We have the function of searching for a certain word or phrase inside the code editor, just like any text editor such as Word or Notepad. In the Sketch tab, we have very important functions, starting with the Verify or Compile option. If we select it, we can start the process of verifying the code that we have written in the editor, and the result of this compilation will be illustrated in what we know as the system's output tray, where it will show us the possible syntax errors that it may have writing our code. Where it illustrates to us at this moment that our code has no syntax errors, and was compiled correctly, and where we can see that the code or sketch occupies 924 bytes or 2% of the available program memory, known as flash memory, and occupies 9 bytes or 0% of available dynamic memory, also known as RAM. But to what memory is this information referring? It refers to the available memory of the Atmega 328P microcontroller located on the Arduino Uno board for this particular case. We have the option to upload. If we select it, we will transfer the code that we have developed in the editor to the development board with which we are working, so that it runs on this board. As you can see, the LED built into the board is flashing every second according to the program in our editor. We have the option to flash using a programmer, but, if to flash any Arduino board we do not need a programmer. What is this function for? Which programmer are you referring to? Well, if we go to Tools, and then to Programmer, a list of programmers compatible with this Arduino IDE appears, among which the programmers appear. Arduino as ISP, since any classic or basic Arduino board can be used as a programmer. In the illustrated link in the corner of the screen, I leave you a video tutorial on how to use the Arduino Uno board as a microcontroller programmer. We find the Arduino as ISP, with Atmega 32U4 chip. The Arduino Gemma programmer, based on the A-Tiny85 microcontroller. The Atmel JTAG ICE3, to program microcontrollers with ARM and AVR architectures. The Atmel STK500, for programming AVR microcontrollers. The Atmel ICE, to program microcontrollers with AVR and SAM architectures. The USB ASP, a very popular programmer for microcontrollers with AVR architecture. I leave you a video link that takes you to the tutorial on how to install and use this programmer. And Tiny ISP USB programmer. All of these compatible programmers are used to load a program made with the powerful integrated development environment of Arduino, the Arduino IDE, into a microcontrolled electronic system, even if it is not made based on the hardware designs of the Arduino boards. Continuing in the Sketch tab, we have the option to export compiled binaries. If we click on the compile or verify our code icon, and look in the folder of the code in question, which is usually in the Documents, Arduino path, we find the folder of our current code being edited, which we call Blink Test. Inside this folder, we find the file of our current sketch stored, corresponding to a file with a .ini extension, being the only file we need to upload a code to a specific Arduino board, through a USB cable and using the Arduino environment. However, what if instead of loading this code onto an Arduino Uno development board, for example, we need to load it into a Proteus simulation on an Atmega 328P microcontroller, or onto a real microcontroller in our own electronic prototype? This file with the INO.extension would not be useful to us, since it only works for Arduino-based hardware systems. We would need the file with the HEX.extension to load it directly to the microcontroller we need. So if we select the Export Binaries option, wait for the compilation, and return again to the Blink Test folder, we can now see an additional folder with the name compiled, and within which we find multiple files, among them the file with .hex extension, with the bootloader and without the bootloader, according to our need. I leave you a video in the link illustrated above, on how to generate HEX files in the Arduino IDE, to use them in microcontroller simulations in Proteus or other electronic simulation software. We also find in the Sketch tab, the Optimize for Debugging option, in case we want to debug the code in real time, for a specific Arduino board that allows debugging to be executed. And we find the important option of including libraries, within which we find a list of several proprietary Arduino libraries that are already predetermined from the moment of installing the Arduino IDE. A library is simply a set of files, with definitions and methods, developed by Arduino, or by a third-party contributor to Arduino, and that allows us to use a set of programming objects that greatly simplify the programming of our code in Arduino to use sensors, actuators, screens, motors, among others, and greatly reduce the amount of code we use as programmers. If you are interested in knowing what a library is in detail, and how your own library is developed, you can access the illustrated video link above to learn. If we want to include one of these libraries in our current code, we can select, for example, the Liquid Crystal library, and we can see at the beginning of our editor, a space also known as scope, the inclusion of our library through an include statement, along A to the name of this library. Liquid Crystal is a library used to operate character LCD displays. If you want to know how to use it to control a display with Arduino, I leave you a link in the upper corner with a detailed video to operate that type of screen. We also find here an option to add libraries are compressed in a zip file. And we also find the option of the powerful library manager. If we select it, the library manager is displayed, which we can also access with this icon from the vertical bar on the left side of the visual interface, and which presents us with a search bar, through which we can search within all the libraries available for Arduino, a specific library, for example, the ultrasonic intended for the simple use of the obstacle detector and distance meter module HC, SR04. If you want to know how to use this distance measuring module, I leave this link in the upper corner to know how to program it with Arduino, to measure distance, to create proximity alarms, and even to count objects. Once we write the library we want to search for, in the search results we will see one or more library packages that execute the function of our interest, in which we must select the one that works for what we want to do. If we are not sure of the function that the library performs, this package comes with a link that says, More information. If we enter this, it takes us to a website with detailed information on the function of the library, where we can learn with a basic reading, what files the library comes with, what examples it comes with, if it has electrical connections it will explain how to make them, and many other things. Once we know that the library is useful for what we want to do, we select the version we want, generally the latest or most recent, and click on Install so we can later use it in the code we are creating. To include this library that we just installed in our Arduino code, we are going to Sketch, Include Library, and as you see, at the bottom, and after the default Arduino libraries, we find a new section that says, Contributed Libraries, making references to libraries that are not developed by the Arduino company, that is, they are developed by third parties, reminding us again that we are in an open source development environment, and that the developments carried out by other people or companies we can incorporate them into our Arduino development environment. So here we see our newly installed ultrasonic library. If we select it, we can see how it is included in our sketch or code. We can remove its installation if we want with this button, in case we do not need to use the library at the moment. Then we go to the very important Tools tab, where we find the Auto Format option, to format our code according to coding conventions. We find the Archive Sketch option, to compress the sketch into a zip file. We find the Library Manager option, which we already saw in the last Sketch tab. We find the Serial Monitor option, which is very important since it will allow us to communicate via serial the Arduino board that we are using, with our computer. If we select it, a window is displayed below the code editor, with the name Serial Monitor, and which will allow us to communicate with the board we are programming. But which board? Well, the board that we have selected here, since we can have several Arduino boards connected to different ports on the computer. On the serial monitor we find a message bar, in which we can send messages from our computer, through the USB cable, to the Arduino board that we are programming. We find another message bar, in which we can receive messages, that is, we can view the messages that are transmitted from our Arduino development board to the computer. At the top right of the monitor, we find a selection list for the termination characters of our sent message, that is, characters that are transmitted after our sent message. For example, after the word hello, we can select no character to send, the NL, or new line, character, the CR character, or carriage return, or both CR and then NL. It also has a list of options where we must select the transfer speed at which this data will be sent or received between the computer and the Arduino board. I will set it for example at 115,200 bauds, or bits per second. Let's see how we can receive data from our Arduino Uno development board. In the code that we have in the editor, we are going to comment on the part that makes the LED blink. Inside the void setup method, a method that is executed only once when the Arduino board is electrically started, we will start the serial communication interface of the board with a speed of 115,200 bauds, equal to the speed that we have configured on the serial monitor, so that both devices can communicate. Then, inside the void loop method, a method that is executed cyclically, we will place the transmission through the serial interface, the micros method. This method allows us to extract how much time has passed since the Arduino board was electrically started in microseconds. I'll set a delay of 1 millisecond. And with the upload icon, located in the second horizontal bar, we will upload this sketch or code to the Arduino Uno board. And here we can see in the receiving box of the serial monitor, the elapsed time in microseconds, which is sent to us by our Arduino development board connected to the USB port of the computer. We can find the access icon to the serial monitor also in the upper right part of the screen, the magnifying glass icon, and every time we access the serial monitor, and in the case of the basic Arduino boards, the program will run again from the beginning. Continuing in the Tools tab, we find the Serial Plotter option. If we select it, it shows us graphically the same thing that was illustrated on the serial monitor, the elapsed start time of the Arduino board in microseconds. It is a very useful tool when it is required to graphically visualize the behavior of a sensor located on the Arduino board. We also find the option, Firmware Updater, to update Arduino boards based on ESP32, S3 or with Wi-Fi modules. We also find the Upload SSL Certificate tab. Since some Arduino boards have internet connectivity, such as the Arduino Uno R4, or some boards from other manufacturers such as the ESP32 from Espressif, and can offer us services through their connection. Just as happens when we enter to a validated web page, we can enter through this icon, and we can confirm that we are in a secure web connection, through an SSL certificate, in which we can understand that our information exchanged with this page is encrypted through keys ensuring that our credit card and other data is not visible to anyone. Likewise, we can include SSL certificates in our Arduino IDE, which allow us to have a secure connection over the internet with Arduino boards or boards from other manufacturers that provide us with web or connectivity services. We also have the board option, a very important option that allows us to choose which board I am going to program from my Arduino IDE, the Arduino Uno board, the Nano, the Mega 2560, among some others illustrated here. And it allows us to access the board manager. If we select it, it will open a vertical column, where we can see all the Arduino boards manager that can also be accessed with this icon, and that allows us to manage the resources to be able to work with them in Arduino, resources for boards other than the ones we know that come predetermined with the initial installation of our Arduino IDE software. In addition to finding Arduino boards, we can find multiple boards from other different Arduino manufacturers, such as the popular ESP32 development board with Wi-Fi connectivity. If we write, for example, ESP32 in the search bar, we can see in the results a package corresponding to the ESP32 boards from the manufacturer Express if for some reason, the board package you want to install does not appear in the search results, in this case the ESP32 board, we can still tell the Arduino IDE in which web address or URL it can locate this resource. If this is your case, you can go to File, then Preferences, and you can enter the icon for the Arduino Additional URL Manager, and in this you can click on the link to manage URLs from manufacturers other than Arduino. A list with different URLs or internet resources will be displayed with boards from multiple manufacturers listed alphabetically. You can scroll until you locate the resource of your interest, in the case of this example, the one that corresponds to the Express if ESP32 boards. You can copy the link that appears next to it, and paste it into the Arduino URL Manager. Let's also assume, for example, that we want to install the resources to be able to program the popular ESP8266 Wi-Fi modules, also from the Express if company. Then we locate the resource for the ESP8266 community, we also copy the link next to it, and we paste it into the URL Manager, separating it with a comma from the URL or web address that we previously pasted for the ESP32. We click on OK, and then OK again. We can then search again in the board manager, typing ESP32 in the search engine, and here we find the package to operate the ESP32 boards. And if we search for ESP8266, we will also find in the results the package corresponding to this type of boards. As an example, let's install this package for ESP8266. And once the installation of the package is complete, which can take up to a couple of minutes, we do the same for the ESP32 boards, we search for them in the search bar of the board manager, and once they appear in the results, we click on Install. It may take several minutes depending on the speed of your internet connection. And that's it, we can see a message indicating that the installation was completed. Once installed, we can go to Tools, then to Board, and here, in addition to the default Arduino boards, we can see an additional tab for the ESP32, with a list of all the ESP32 boards supported to be programmed from the Arduino IDE, as well as another tab for ESP8266, with an equally extensive list of all the boards supported for this ESP8266 chip, and which from this moment can be programmed from our Arduino IDE. Something very important, my dear friends. If we go to File, and then to Examples, we see multiple example codes, to operate a keyboard, to operate an LCD screen, to write or read an SD memory, to control a servo motor, to operate a TFT touchscreen, these being examples that we can use with an Arduino Uno board, since so far it is the board we have selected. However, if we go to Tools again, then Board, and in the ESP32 tab we select, for example, the ESP32 Dev Module board, we verify that it has been selected, and we go to open the examples again, we will see that this examples tray has been updated for the new ESP32 board that we have selected, understanding with this that each package for each installed board, whether from the Arduino manufacturer or from a third party, will come with its list of example codes from which we can generate the final code for our need. We have the option to select the COM port, or USB logical port, in which the board of our interest is located. We find the board information option, where we can obtain basic information about the board, in case of original Arduino boards. We find the programmer option, with a list of different programmers compatible with the Arduino IDE, and which we explained in previous chapters. And we find the option, Burn Bootloader. The bootloader or boot manager is nothing more than a small program that is generally pre-recorded at the factory in the main microcontroller of the Arduino boards, and that allows you to activate the communication resources of the Arduino board in such a way that it allows load programs without the need to use external programming hardware. However, there may be times when we need to load this bootloader file to the microcontroller again in order to program the board from the Arduino IDE. In this case, you can see the video that you see on the screen through the link in the upper corner to learn how to load it in a microcontroller or on an Arduino board, demonstrating once again the great integration capacity of our Arduino development environment, the Arduino IDE. Lastly, the important tab Helps, where he illustrates the option, Starting. If we select it, it takes us to the Arduino documentation to start working with this platform, from its installation, to the basic knowledge of its boards. We have the environment option, which takes us to an article that basically explains how to work with the Arduino IDE software. We find the troubleshooting tab, which takes us to the website where it guides us to solve problems with the hardware or boards, with software or Arduino IDE, with the cloud code editor, with the cloud connectivity platform. If you want to know how to use the Arduino IoT Cloud platform to create IoT devices with connectivity over the internet, I recommend the video that you see on the screen, accessing through the link in the upper right part of the screen. And problems with access to the Arduino educational platform. We also find a very important option, called Reference, where we find all the standard Arduino functions or methods that we use repeatedly in our codes, for operation of digital and analog pins, mathematical functions, trigonometry, timing, advanced functions. If you access any of these methods, you will see a detailed explanation of how to use it, what its syntax is, and many other things. You can also see here the types of variables and their main characteristics. And you can also see the different control structures used in C++, and that will be key for programming our sketches. We also find here the search function for a specific Arduino reference. Common questions. The data privacy policy in the software. And a very important option, for checking updates, from which, starting with version 2.0 of the Arduino IDE, you can update from here the latest available version of Arduino, without modifying the files, sketches, or the work that you already made in its current version. A special greeting, friends, from Electronic Spot, and see you in the next video.